we find 1, 3, 5, 7, 9 are in a pattern. That means these are positive odd numbers. If two sets have same elements, then we call those two sets are equal. For example, set of x such that x lies in between 0 and 5. This is a set. We call it set of intervals. Let us take one example. I have taken this example. Set A, members of that set are 2, 4, 6, 8, dot, dot, dot. Now we find that we can arrange the members of this set as in the order of the members of the set of natural. Then we say that set A is countable. Now one thing, countable set may be finite as well as infinite. When we can arrange the members of the set given set in order, that means the members of the set follow some pattern, then we say that is countable. This is infinite. It is called countable infinite. Countable infinite because we cannot count the members or elements of this set. Therefore, this is countable infinite. But members or elements of this set have one-to-one correspondence with set of naturals. Therefore, this is countable set. And as we cannot count the number of members, it is countable infinite. But if I take this example, we find 1, 3, 5, 7, 9 are in a pattern. That means these are positive odd numbers. Therefore, this is also countable set, but this is countable finite. Now, countable sets are also called enumerable or denumerable. Countable sets are also called enumerable or denumerable sets. Therefore, enumerable, denumerable are synonyms. Sets are synonyms of countable sets. Now, if we cannot count the number of elements of an infinite set, then that set is called uncountable infinite set. Actually, uncountable set is infinite. Now we move to compare two sets, two or more sets. Equivalent sets. If two or more sets have same number of elements, same number of members, then we call those sets as equivalent. We take example A. What we find, number of members of set A is 3, number of members of set B is also 3. That means n A, cardinal number of set A is equal to cardinal number of set B. Then, but the elements are different, therefore these two sets are equivalent sets. Next we come equal sets. If two sets have same elements, then we call those two sets are equal. For example, set of X such that set 1 S1 have members 1 and 2, S2 have members X such that X satisfies this equation, x square minus 3x plus 2 equal to 0. Now, are these two sets equal? For that, we first express the set S2 in tabular form. For that, we solve the equation x square minus 3x plus 2 equal to 0. That is x minus 2 into x minus 1 is equal to 0, which gives x equal to 1 and 2. Therefore, S2 is equal to set of 1 and 2. Thus, we find S1, S2 have same members. Therefore, we compare these two sets as S1 equal to S2. These two sets are equal. Now, what we find, in case of equal sets, the sets will have equal or same cardinal numbers, as well as they have equal or same members. Therefore, in case of equal sets, we can say if X belongs to set A and any member of the set A is also member of set B also, or and we can use here the term and any member of Y is a member of B, that implies Y is also member of A. This symbol is used for implication. That means X belongs to A, meaning of that is that X belongs to B. Then if we find these two are occurring, then we conclude if we find X belongs to A implies X belongs to B and Y belongs to B implies Y belongs to A, then the conclusion is the two sets are equal. Also, if the two sets A and B equal, then we get these two. This symbol implies that next we have few more sets. Number one, set of real numbers which are also intervals. Example, set of x such that x lies in between 0 and 5. This is a set. We call it set of intervals. Also, these are set of subset of set of reals. This is set of intervals. One set of intervals. Also, we write this in this form. Set of intervals. What does it mean? Meaning is that the value of the variable will lie in between 0 and 5, but the variable cannot take the value 0 and 5. If x can take the value 0 as well as 5, we express that in other words we call it open interval. And this is denoted by this symbol also. This is closed interval. Generally we express set by using curly brackets, but in case of interval we use first brackets and third brackets. Then there is another type of sets, set of sets, set of sets. Let us take this example. Set of null set of 1, set of 2, set of 1. What we find? All the members of this set are set themselves. Therefore, this set S is set of sets. Then we move to the next matter, subset and superset.